This video will provide general information about the use case titled Robot Workcell Reconfiguration. Before providing general information about the use case, a brief presentation of our department will be given. The Department of Automatics, Biocybernetics and Robotics is part of Jožef Stefan Institute in Ljubljana, Slovenia. While we conduct basic and applied research in the multiple various areas, the topic of the presented use case is most related to industrial automation. In this area, we conduct basic and applied research in the area of factories of the future and industrial automation. One of our goals is to expand the field of industrial automation through passive and active reconfiguration, modular design of software and hardware architecture, implementation of easy-to-use robot programming, and implementation of digital twins. In the area of humanoid and cognitive robotics, we focus on the development of new technologies for robotic systems that can operate in natural environments and in collaboration with people, with a focus on industrial settings. This is only possible with robots that can continuously and autonomously acquire new sensory-motor behavior and higher-level knowledge. Humanoid robots are, due to their similarity to humans, especially suitable for operations in environments shared with people. The humanoid robot Talos was designed with an industrial setting in mind. The aspect of collaboration, an integral part of factories of the future, is further studied in the area of collaborative robotics. Here we use integrative approach of robotics and machine learning to investigate and study collaborative robot behaviors in physical human-robot interaction scenarios. The study of human-robot collaborating is enhanced by study of human-human and robot-robot collaboration. In the next section, general information about the use case will be given. The ability to reconfigure production cells is crucial for agile production processes where production frequently changes from one product to another. In this demonstrator, we develop a robotic work cell that includes hardware components with passive degrees of freedom to enable quick robot-supported reconfiguration from one product to another without any manual intervention. The developed robot work cell is a reconfigurable manufacturing system suitable not only for large production lines, but also for low-volume, high-diversity production. The developed system enables quick setup and short reconfiguration time with a minimum of intervention by human workers. It offers software and hardware reconfiguration tools that can be used also by users without in-depth expert knowledge. However, if the production task requires new capabilities or modules, users with more in-depth knowledge can develop new software and hardware components without disrupting the already defined work cell architecture. This is due to the modularity and tight integration of both software and hardware elements of the work cell. The developed work cell can be used in any sector that requires automated assembly of a variety of products that change frequently. Some example areas where the proposed reconfigurable cell was implemented and evaluated covers areas from automotive industry, furniture industry, electronic industry, etc. In the automotive industry, for example, the cell was used to implement the assembly of various automotive light housings. The original standard production line consists of specially designed assembly machines different for each light housing model. While these machines provide an assembly method with short cycle times, they are not cost efficient as they have to be designed and produced for each different lighthousing model. To ensure the possibility of assembly of various lighthousings from a family of products in a single work cell, the developed work cell focuses on reconfiguration of housing fixtures within the cell. Implementation of this use case requires basic robot familiarity, basic programming skills, while ROS knowledge is beneficial. For more information and details about this use case, please see the main lecture video for it.